A very good afternoon to all the participants present here. I welcome you all once again for the sixth session of this 6-day FDP program. And today the speaker who was scheduled was Mr. Binod Kumar. Due to heavy rains in Chennai and he's got some power shutdown, he is not able to connect with us today. So instead of him, we have with us Mr. M. Satish Kumar, who is a geotechnical engineer with around 11 years of experience in onshore and offshore engineering. And presently, he is a geotechnical engineer at Neyveli Lignite Corporation. He has completed his ME Soil Mechanics and Foundation Engineering from CEG. So I personally welcome Satish Kumar and thank you so much for giving the presentation at a very short notice. Thank you, Satish.
Thank
And
you.
I'll make you as the co-host so that you'll be able to share the presentations.
Okay.
Yes, please try sharing it.
Is my screen is visible?
Yes, it is.
Okay.
Please go ahead. Thank you.
Okay. Thank you, Logeshwari, for your introduction. I am unable to move for the next slide. Can you able to access that I am unable to move for the next slide?
Actually, we are able to see the first slide. Can you go to slideshow?
Now that it is not taking. Is it visible now?
No, it's not yet. It's still in the first slide, actually.
Let me just check and stop it.
Yeah.
Is it visible now?
Yes, yes, it's visible.
Yeah. Thank you, Logeshwari. Let me just give some brief introduction about my previous work experience. Um, I actually did my master's in Anna University, Chennai. Logeshwari is my classmate, master's classmate, and from then I have started my career in L&T Geostructure as a postgraduate engineer trainee, and I was with L&T for around 9 years. And then I moved to Cove India Private Limited, and I was with Cove India Private Limited for 2 years. And then from since May 27, 2024, I am associated with NLC India Limited as an executive engineer. In addition to that, actually, I'm also part of this syllabus committee member in CEG for this geotechnical engineering department. These are some major work which I have involved this Ram Mandir. 1 minute. Sorry, some disturbance. Sorry for the inconvenience. Am I audible now?
Yes, yes, you're audible.
Logeshwari, can you hear me? Okay, thank you.
Yeah, yeah, I can hear you. I can hear you.
Yes,
Okay,
voice audible, sir.
okay. Yeah, these are the major projects which I did. This first one is
Sir, PPT is not visible, sir.
Ram Mandir temple
No, your profile page is visible actually.
okay. Is it visible now?
Still, it's your profile page.
Okay, maybe some internet issue.
Satish, you have to share your entire screen, not
Yeah,
the
I
window.
am selecting that entire screen only, but
I think if you close this PPT, the other one will come, I think.
is it visible now?
Yeah, your profile only is still visible.
Profile page. Okay, then let me just reconnect it. Sorry for the inconvenience. I hope it is visible now.
Yes, Satish. The second slide of your profile PPT is visible now.
Okay. Yeah. Speed drive, wherein actually support. Then surrounding moved to Cove India Private Limited, which is mainly leading. Was also part of this foundation design team for the flood diversion project. Did this in Denmark? There is an artificial island at a Linet home. For that, I did the stability analysis. Actually, that Linet home project. In this is that high speed rail foundation support design. So then I'll move on to this actual topic today is this geotechnical and foundation engineering. Is this geotechnical and foundation engineering slide is visible?
Yes, your content slide is visible.
Look, okay, yeah, thank you. Yeah, this is actually the content which I'm going to cover mostly today. Introduction to foundation, geotechnical investigation, field load test, deep foundation, and ground improvement. These are actually the major topics of our what we need to refer for these things. Then I'll be going with that typical work which me wherever you have it. Investigation mainly we are carrying out towards responsibility of sites, adequate, safe, and economic design. So when it comes to investigation, uh, 1 to 2% of the amount for this geotechnical investigation, which has actually some can say huge amount of works are the superstructures. Mainly the soil data required for this any design of the geotechnical system limits for that soil group classification. And when it comes to strength and compressibility characters, which is defining your bearing capacity or the settlement which of internal friction, unit weight, water content, permeability, maximum dry density, optimum moisture content, core recovery RQD, and UCS value. In addition to this, we need to measure this water table depth also, which is actually having classification which is given in IS 1498 based on that grind size analysis. You can categorize your this coarse grain components more than 4.75. It is being treated as a gravel. More than 75 is being treated as a cobble, and more than 300 is real silt, clay, and organic matter. So I would say instead of fine grained components, I can say it as a problematic soil. So this silt and clay is going to be the major issue when it comes to the foundation design, especially under the water table. So this is typical results which we'll be getting from the grain size analysis, wherein you can classify your soil group as whether it is sand or silt or clay. So if it is having combination of clay, silt, and sand, then we can categorize as C5 soil. And again, based on this curve, coefficient of uniformity and coefficient of curvature, you can arrive at your grading nature of the soil, whether it is well graded or poorly graded. Based on that category, actually, you need to select the soil for some of the filling works. So this also has some major significance when it comes to design. So this is actually a typical drainage analysis results what we have obtained for one of the project. So predominantly you see this soil is most of the soil are coming in this area, which is and this pattern also you see it is shaped. So I can say in all the area this soil is actually present. So then approximately it will be in the range of 12 grades. I just categorize what are the test it is available in general. So direct method, boring, drilling with sampling penetration tests such as dynamic cone penetration test, then plate load test, in situ intensity field CBR, dynamic test for properties of soil. Actually, these are all the tests. Mostly it is available in the geotechnical investigation, but in practical are going the test results also easy. In that manner they are going, but when it comes to accuracy, it is actually a question. Reliability on the parameters, actually we need to pay more attention when it there are so many authors they have studied about this standard penetration test, and they had preferring to go with the standard penetration test. This other test, like I would say in our Indian projects, hardly we'll be going with once in 10 to the test results, but our in Indian projects actually borehole investigation. Then this indirect method is the laboratory test. So this actually you people mostly aware because that is part of our curriculum and we were in UG or PG. So these are like one of the typical trial pit. Actually, this trial pit will be recommending to collect that block samples to identify the nature of the soil when that work foundation is restricted to shallow depth. Mostly trial pit will recommend in case of road works, because there that influence depth of the road is going to be less. So in exactly it is 300 meter, but this trial pit it is quick and easy, so we'll be recommending at 50 meter or 100 meter. Then this is the typical photos which is being taken at the time of soil investigation. Investigation at various found soil. This is actually borehole drilling in River Ganga with the help of this boat. This is actually offshore mode, and this is actually in marine mode with the help of barge. This investigation is being carried out in one of the river. marine work. Previous authors might have been covered this explanation about this SPT test. One thing I would like to emphasize is actually that correction for that SPT test. There are other manuals and references where the tendency we need to perform this rod length and hammer efficiency correction and this sample diameter, bore diameter. There are some other aspects also. It is there is some additional interest to be connected with conveyors stockyard to the jetty. So material will be through the navy. So this is actually for the conveying purpose. So we just made this at irregular intervals. Usually, if it is similar in shape, the corner. This sort of structure, mission first. What are the existing boreholes it is available, and we need to plot the subsoil section. Based on that, first we need to arrive at the preliminary soil state at that particular location. So if we are having sufficient number of boreholes, then we can actually do this investigation as a confirmatory investigation. So this is, I would say, one of a confirmatory investigation which we did because we were having some additional boreholes in the initial stage itself. That's why you can see that the boreholes are placed at irregular interval. We just fixed that the depth of the rock. To confirm that depth of the rock, we have actually recommended these boreholes. This is one typical bore log which we actually obtained from the field test. Actually, these are all the basic information a bore log should cover. What type of it is being used, and then the boring diameter, casing diameter, and when it was actually executed, and exact location. So these information should be there, and then the water depth or water table which is encountered at the time of investigation. Then here actually it contains the information of the rock, so you can see core recovery and RQD is there. If it is actually SPT test, you might have been seen that SPT number here. So this is typical bore log, and this is typical subsoil profile which is being generated using the soil investigation data, which is arrived in the field and the lab. And this profile is being made with the help of GIMP software. So you see that it will be actually helpful to arrive at the rock starting level, because in this project we need to terminate our pile on the rock. So you see this hatch pattern grade 5 rock at the pile foundations. The pile foundation are actually mainly recommended when that the superstructure load is more, and then if your take care of the bearing capacity which is offered by the soil. And when it comes to riverfront structure, again, this pile foundation is only mostly recommendable because construction of open foundation or wrap foundation in the waterfront go with the pile foundation. So mainly for the piles, it is actually compressive loads, uplift loads, and horizontal loads going to act on the building or the superstructure. Then this lateral load or that eccentricity of that the lateral load. Then uplift load actually mostly it will be completely and those are the major location wherein you can find out that uplift loads. And we have revised the type of pile. We have used both the cast and situ pile, driven cast and situ pile, and in some of the locations near to this Manadi and all, we just went with this precast driven pile for that supporting structures, not for the main bridge structure, but there are the office buildings for which we went ahead with that precast pile foundation system. The mean pile load transfer and friction piles. So when you are placing your foundation in the sandy strata, the main resistance of the pile would be generated through this friction. So when the load is in compression and because of that interfacial friction between this pile and soil material, there is going to be a resistance. That is your friction resistance. Uh, this is how your friction force is being developed when that compression load acts. This is one typical pictorial representation how that soil will hold the pile when the load is acting on the top. When it comes to end bearing, let me say if I have a soft soil of SPTM value less than 4 for a depth of let me say 12 meter or 30 meter, 13 meter, I cannot embed my pile into that soft soil, so I need to search for a stratum which is of actually rigid. So in such cases, actually the resistance would be mainly developed by the rock. Whatever load it is being applied, it will be directly transferred to this hard strata since this is not going to offer any resistance because of this low conductivity or stiffness. To estimate this bearing capacity, mainly I would recommend IS 2911. If any Indian project comes, actually, most of the cases it would be as per IS 2911, wherein this pile capacities are being explained by static formula method and dynamic formula method. So it actually having two components. One is your frictional resistance and another one is bearing resistance. So frictional resistance would be based on peripheral area, surface area of the pile. And when it comes to bearing resistance, it is actually based on your cross-section area of the pile. So this that portion which is actually contacting to the bearing strata, that area will be taken and that resistance bearing resistance will be taken. Unit bearing resistance multiplied by cross sectional area will be your to take only the friction resistance which is developing in the pile because the pile is being lifted in upward direction. There is no, if there is a loss of contact between the bearing state, we need to consider on which is being developed in the side of the pipe. So that is your safe skin friction capacity in the into the reduction factor or safe capacity factor, which is given in IS 2911. Usually, it will have this history or test results, then you can go ahead with the factor of safety of 2.5. When it comes to lateral capacity, I already said that it is actually a major factor of concern when it comes to waterfront or marine front structures. The major lateral forces are this wave and current force and also the wind force, which is actually on the exposed portion. So this free head condition and fixed head condition, whatever approach which was so most of the cases when it comes to marine structures or waterfront structures, more than vertical capacity, this later capacity is there requires the suitable depth of fixity to generate that long tail behavior. So in such cases, mainly this lateral load is going to be the governing one when it comes to the waterfront structures. How that design is being different soil information available at that particular location. We are not performing any continuous drilling all along the pile area, but for which we will be recommending this termination criteria. If it is continuous soil, then we'll be giving fixed length. If it is varying in strata means, then that minimum amendment what it is like a 3 length is given in IS 14593. So that minimum socketing length should be there in the weather drought. So such sort of termination criteria will be given in the pile design drawing. So that because they cannot identify the specific same strata what we have encountered in soil investigation. So in such cases, this termination criteria would help to stop the pile action. And then the reinforcement details, which is being designed for the ultimate load. So when it comes to we are actually based on the load. When it comes to feed, actually we need to verify. So for example, if my load tractor based on the load combination, there are a lot of load with the initial test load, the design load. So this initial pile load test, actually it is a sacrifice the pile which will be casted only for testing purpose. This routine load test means the test will be conducted on the working pile which is being constructed for the actual live condition. And then again, pile dynamic test and pile integrity test. This pile dynamic test method, not regular test like initial load or test. This is one of dynamic method which is used to replace the static load test. For example, we have this Kent and reaction pile method. If at all, if you have any space constraint or some other instance, then you can go ahead with this pile dynamic test, which actually no need of any something. Wait for pile construction. When you are fabricating a column or constructing a column in the surface, you have a proper shuttering and you have a proper chance of honeycombing is being very less in when it comes to the column which is being executed in the surface. So this is how that hydraulic jack, and that whatever uplift load comes here, which will be substantiated by concrete blocks or steel, and for your convenience, you can in this jack. So this is how the cartilage method actually we have carried out in using concrete blocks using steel. This is the load was 4,000 tons. So which was the actually cartilage method for 4,000 tons. We are actually not having suitable space went ahead this method. This is how that both concrete block and the steels were used as a cartilage weight in one of the project. In so arrest the load which is coming from the upward direction of the jack. So resistance are being considered as a resistance for this uplift force comes from the jack. So this is called a reaction pile method. Then this was the setup actually I was explaining that here actually these concrete blocks are placed in the ground because that load is actually 100 tons or 200 tons. So bearing capacity at this location was around 5 ton per meter square, and the load which is coming on the block is less than 5 ton per meter square. So we actually proceeded with this concrete 1,000 tons. We are actually unable to place this concrete block that concrete blocks directly on the ground. That beams actually over that reinforcement setup being made. The test bed is actually under this beam, and these are all like a temporary support pile if I place this concrete. So to support that, again a separate temporary foundation systems are made with the help of this liners. So this is actually hectic job while executing this, and finally we executed that's why you see that that beam and arrangement sizes. This when you are applying force on this pile, this was actually arrested with the resistance from the nearby pile. So this is how that the lateral load is being performed at the site. Load is applied, and the movement of this pile in other direction is displacement behavior is being plotted, and based on piles are 5 mm. So when it reaches 5 mm, then we need to stop the test, and we have to recommend the capacity corresponding to that 5 mm lateral load. Another view you see here that strain cages are fixed, and that movement is being monitored. This is another method of pile load test, which is of anchor method. Instead of reaction piles, anchor systems are being used to resist the load which is coming from the jack. Firstly, we saw that compression test and later test. Now it comes to pull-out test. So this pull-out test, the uplift loads will not be there in all the piles, but there are some piles when it comes to this marine area, when there is berthing or mooring up action, there would be that compression load in the front area piles and tension load at the rear area pile. So for that pile, we need to perform the tension capacity. So again here for this tension load test, cartilages are actually not preferable. We should go with this reaction pile method. When you just hit that pile, there should be a wave propagation in the concrete, and when it reaches the toe, again it will comes back to the pile. This is actually the top, and this is how that wave pattern should be. So this is actually pile. You can see that the proper peak at the beginning and peak at the end. You see this bad pile, that behavior, there is actually undulation. The shape is not clear. This is there that hammer will be prepared with a suitable file there. So when it reaches our test load, then that test will be stopped. So for this in dynamic file, so that will be measured that wave speed and the force which is being generated in the file. Wave propagation theory is the background behind this file drivability analyzer. So that is actually different concept. So let me just stop here and we can have a. Am I audible?
Yes, you're audible.
Okay. Any question or I can proceed for the topic, next topic.
Just a doubt. Uh, I think I don't know whether my network is bad or what. Your voice, your video is getting broken actually. Is it the issue only with me or is any other participant facing it?
No, no, it is the same with everyone. I could not hear most of his
Okay.
words.
Maybe some bandwidth issue.
Yeah. Can you just correct it?
Is it clear now?
I think it's
Yeah,
fine.
perfect. Yes, yes.
Okay. Okay, so let me know, like, related to this soil investigation or piling, if you guys have any doubt, you can ask. We can discuss. Maybe not in line with the presentation what I made. In general, if any doubts related to soil investigation or pile foundation or shallow foundation, you can raise. I can try to answer. Okay, then if there is no question, then I can proceed for that next topic. Is it okay, Rageshwari? I can proceed, right?
Yeah, yeah, yeah. But please try to wind up in another 15 minutes. We are running late.
Okay. Okay. So is my ground improvement screen is visible now?
Yes, yes, it's visible. Yes. Yes, visible. Yes.
Okay. Okay. First thing I would like to note that
It has started to break, Satish. I'm not able to hear you actually.
now I'll be giving a brief glance about this ground improvement techniques. Then I have actually a separate slide for pile construction methodology, which is being executed at a particular site location. So when it comes to ground improvement techniques,
Sorry to interrupt.
ground
Satish?
improvement
Satish?
if your
Satish?
subsoil is not
Satish?
actually
The,
complete.
Satish, the network issue still has not become all right. It's still breaking. Your voice is still
and
breaking.
enough to bear the load which is coming from the superstructure based on the soil type. One is dynamic is an issue. Normally you want to exploit the consolidation path chemical modification which is of actually deep soil mix but raining continuously maybe because of that any bandwidth issue or something. Shall I proceed?
The network issue is still there.
Logeshwari, shall I proceed?
Yeah, the network issue is still there,
Okay.
Satish. It's breaking in between, breaking.
Okay. So yeah, I just checked it actually because of that climatic condition here that
Yeah, yeah, yeah.
network fluctuation is whenever it needed. Yeah, then this chemical modification techniques, then reinforcement using vibrostone clear. Is it clear now? Logeshwari, can you hear me now?
Yeah,
Yes,
yeah,
yes,
yeah.
yes, yes.
Okay. So is this TCS series slide is visible?
Yes,
Yes.
sir.
Okay, yeah. So firstly, actually, we did the series geotechnical investigation to identify the subsoil condition of that particular location, wherein we have identified that the top 3 meter is a clay layer, then followed by weathered rock from 3 meter to 10 meter depth, then beneath that hard rock encountered. So this was actually the stratigraphy of that particular location. You can see silty clay, then sand, and then rock from 10 meter to 25-meter depth. So for that silty clay layer, SPTN value was observed as 3 to 15, and in the sand layer, it was varied from 22 to 100. And in case of rock, core recovery range values were in the range of 53 to 100, and in RQD, it is actually 0 to 100. So the foundation type which we have recommended for this particular case is a board calcium situ pile of 600 mm dia, uh, with a length of means which was actually terminated in the rock. Vertical capacity of the pile is 1500 kilonewton and lateral capacity is 75 kilonewton. So at this site actually we have executed 291 piles, and then diameter with a 450 ton capacity, and piles proposed for the area other than tower area is 600 mm diameter with 150 ton capacity. Actually 26 piles were completed within a day. Actually they have completed 26 piles. So this is actually the seek of the board pile construction. Firstly, pile position will be fixed with the help of the surveyor based on the coordinate which was given in the drawing. The center point of the pile will be fixed. Then around that area, for placing the reinforcement and concreting, that preparation will be done, which required to place the positioning of the piling rig. That board casting situ machine needs to be placed near to this particular point to boring, and then firstly we need to install the casing, then boring with the bentonite or casing. Actually if it is with a temporary guide, it can directly proceed for drilling. Then after reaching the required depth, the base of the pile is cleaned. Then after cleaning, we need to lower the reinforcement cage. Then we need to lower the trimmy pipe. With that trimmy, actually, that bentonite slurry inside that borehole would be fixed. Then whatever that concrete which is actually excess at the top, that needs to be chipped off. So this is actually the step-by-step procedure of the board casting situ pile installation. This is actually the pictorial representation of that thing. Firstly, that piling rig is placed near that pile boring point, and then temporary casing is being lowered. Then soil is removed inside the boring location, and means inside the boring, it is being replaced by bentonite slurry, so that borehole collapse will not happen. So that bentonite with a suitable den will be placed inside the borehole. Then the reinforcement cages will be lowered inside the borehole. Then using the trimmy, that the concreting is being done, and then this is the shape of the completed pipe. So this is that typical site location photos which was taken. This is that hydraulic rig which was used to execute the pile, and this is one photo which was taken with the help of this crane. This pile reinforcement cage is being lowered inside the borehole. Then this was the transit mixture which is used to pour the concrete from the batching plant. Then this hydrometer is being used for the recirculation. So the material placed in the pile is being property of the bentonite needs to be checked at frequent interval so that there should not be any borehole collapse. This is and sand content of the bentonite needs to be checked at frequent interval. This is bentonite tank arrangements. This was actually so then we need to just make a sort of boring with the help of a piling rig. Then this is checking of the center of the boring location. So after the casing is being placed, we need to check the orientation of the casing, whether it is actually at the exact location or any tilt or misalignment. Then that boring action needs to be done with the help of a boring machine inside the casing. This is actually a tube which is connected with the bentonite's retank, through which actually that bentonite is being circulated inside the boring. And then that bentonite is being tested for that quality, viscosity, and density. Then this is actually that flushing of borehole. So once that rectangle is connected with the if you are leaving for a period more than 30 minutes, then it will be actually water. So continuous flushing needs to filter cake or something. This reinforcement cage actually lowered with the help of this crane reinforcement. This which actually concrete is being carried out. This was that rigs which were used at that project. So I will stop here. We can have some time for question and answer. Any questions?
Sir, your voice is not clear, sir. I'm not received your voice, sir. Please.
Any questions?
Thank you for
Am I
your
audible?
valuable. Yes, sir. Right now, audible, sir. Okay. Thank you for your valuable presentation, sir. Regarding foundation, pile foundation, you are explained a very nice manner, and then your pictorial representation, which is showing that all the parameters which is involved in piling techniques. Thank you for your valuable presentation, sir.
Thank you. Thank you.
If any participant is willing to have a conversation, have a discussion, we can have it now. We can spare a couple more minutes on it. I think there is no discussion. Anyways, Mr. Satish, thank you so much for giving us a presentation in a very short notice. And of course, the network issue was there, which is unavoidable. You can understand that. And thank you for sharing a lot of insights, pictures, and everything. Thank you so much once again.
Ma'am, link not at
Yes,
center, please.
yes, sir.
link, feedback link is not received.